Hi, in this video we will give an introduction how to use OPC with Visual Studio. In this video we will use the following software. We will use the Matricon OPC Simulation Server, which is a free server you can download for free on internet. We will use Visual Studio and we will use the Measurement Studio. The Measurement Studio is an add-on package to Visual Studio created by National Instruments, which is the same vendor as LabVIEW. With this add-on package, you can easily create OPC clients with the Visual Studio code. So the Measurement Studio is an add-on package created by National Instruments, and it makes it possible to communicate with an OPC data access server from Visual Studio code. This package uses the data socket library, which is the same you would use in LabVIEW if you want to communicate with an OPC server from LabVIEW. So what is OPC? OPC is a standard that defines the communication of data between devices from different manufacturers. You typically require an OPC server that communicates with one or more OPC clients. We have different standards. We have OPC direct access, OPC historical data access, OPC alarm and events, etc. So here you see the typical scenario where you have an OPC server and you have one or more OPC clients that communicates with the server and share data. So here you see a typical example. Here we have a PLC, a distributed control system or a SCADA system that control a process and measure some data within the process, and those data are sent to an OPC server, and then we could have multiple clients that read data from the OPC server, but we could also have OPC clients that write to the OPC server like this. And all these clients could be distributed in a network. So here we see some OPC specifications. We have what we call classic OPC. So this is the first specifications that came with OPC. Then we have this OPC direct access, which is used for real-time data. And we have the OPC historical data access, which is used for historical data. And then we have the OPC alarm and events that is used for alarm and events. A few years ago, the next generation of OPC was released, and this specification is called OPC UA, UA for Unified Architecture. Yeah, so here we see these specifications. And those three are the most common in classic OPC, and then we have this new OPC Unified Architecture. With this classic OPC, we have this problem with the COM and DCOM communication. If we have multiple clients and servers in a network, there is a problem sending data between them. Because OPC, the classic OPC, is based on COM and DCOM. Another thing, in OPC Classic, you typically may need more than one OPC server, or at least one OPC server that supports different standards like this. While in the OPC UA, all these standards are defined within the same standard like this. Here we also see the typical problem with classic OPC. If you use classic OPC in a network, we will have a problem sending the data between the server and the clients because of settings in the firewall, etc. Because modern network don't don't really support the DCOM standard, because you need to have lots of configuration in order to make this work. So typically in this case, we need to use a tunneler software that makes this communication easier. But in a more modern approach, OPC Unified Architecture, the configuration we need to set up is much easier, because this protocol uses the more modern web standards like HTTP, etc. Yeah, here we see some examples also. In classic OPC, the clients and the server needed to be a Windows computer. But with OPC UA, you could use different kind of operating system like embedded system, Linux, Windows, or even Macintosh or OS X. So the different clients could be a computer, it could be an embedded system, etc. like this. Since we are going to use the Matricon OPC simulation server in this video, we are going to give a short introduction to that OPC server. So the Matricon OPC server, you can download the Matricon OPC simulation server. You can download it for free on the internet on the homepage of Matricon. In addition to the OPC server, the package also includes an OPC client called Matricon OPC Explorer. This OPC client is handy to use when you want to check your communication between the server and the client you are create. So in this Explorer, you just choose the server you want to connect to in the list to the left, and then you click connect, and then next you can add tags you want to monitor. So then when you click add tags, you will get access to the folders on the OPC server, and if you click one of the folders, you will get the tags in that specific folder. So select the folder you want to use. Typically with this server you have lots of tags you can use. You have some random tags that just generate some random data. If you want to test write and read communication between clients and server, you could typically use the bucket brigade tags. So if you click bucket brigades, you will get lots of different tags you can use. So you just select the tag you want to use, double click, and then next click on the add button here, and the tags you want to monitor will be listed in this list. And here you see the value, quality, etc. of that specific tag. You can also right click on the tag in order to write data directly from the Explorer, like this. We will use the add-on Measurement Studio in order to communicate with an OPC server in this video. So the Measurement Studio is an add-on package to Visual Studio created by National Instruments. Measurement Studio has the same vendor as LabVIEW, and this package makes it possible to communicate with an OPC direct access server from Visual Studio Code. This package do not support the OPC Unified Architecture. We use the data socket library, which is the same library we use if you want to communicate with OPC from LabVIEW. You can download Measurement Studio from this download, or just search on Google. And then you can use the same license number for as you do use for LabVIEW. Measurement Studio and Visual Studio comes in different editions. If you have Visual Studio 2013, then you can use Measurement Studio 2015 without problems. If you have the newest Visual Studio edition, Visual Studio 2015, then you need to do some manual steps in order to make it work. These steps are found in these documents, but I will go through the steps briefly. First, if you use Visual Studio 2015 with Measurement Studio, then everything should work as expected. Then you can use the Measurement Studio templates that are installed by Measurement Studio installation package. So you just select new project and then select Measurement Studio, and then you have multiple templates you can choose between. Typically you use the NI Windows application. When you have selected the template, you need to select which part of the library you need to use. Typically in the OPC example, you need the data socket library like this. So this needs to be selected. If you have the latest version of Visual Studio 2015, you need to do some manual steps in order to make it work. For first, the templates shown in the previous slide are not available. So in this case, you just need to use an ordinary WinForm application, which you find in the new project template, Windows and Windows Forms application. Then you need to add some references or assemblies manually to your project, and then you need to change or update the license file. So let's start adding the references. So in your project, you just right click on the references like this, and then you need to browse for your assemblies, and typically you find it under Program Files, National Instrument and Measurement Studio, and the edition you install, and the folder Assemblies and Current. And in our case, we need to add these two assemblies to our project. Next is the license file. You need to manually set the public key token according to this. So let's start with a simple OPC read example. So in this example, we will read values from the OPC server, and in this case the OPC server is the Matricon OPC simulation server. So the example works like this. Here we see our graphical user interface that we create in Visual Studio. So we just need a text box, a label and a button. And in this case, when we click the button, the value from the OPC server for the specific tag we use should appear in the text box like this. So in this example, we just use the Matricon OPC Explorer, and then in this example we will use the Bucket Brigade Reel 4 tag, and then we can, in the list, we can just right click, and then we can write a value to that specific tag. And when we have done that, we can click the Read OPC button, and the value we read right here should be shown in the text box like this. Here we see a piece of the code we need to write in this example. First, we need to include the namespaces for the assemblies we are using, and then next we need to set up the tag we are going to use. In this case, we are going to use the Bucket Brigade Reel 4 tag, and then we just create a new data socket object, and then next we just check if the connection to the OPC server is if the connection is already there. If it's connected, then we just disconnect, and then here we connect to the server. And in this case, we just use the access mode read in this case, since we are only reading from the server. And then we use the update method in order to get the latest value from the server. And in this case, we just convert the value we get from the OPC server like this, and then put it into a variable. So let's run this demo inside Visual Studio. So here is my Visual Studio project. In the Solution Explorer I have the OPC read project, and you see under references I have added those two assemblies. So in order to add those, you just right click on the references, click add the references, and then select browse in order to find the assemblies on your hard drive, like this. Typically they are stored in the program files, National Instruments, and the Measurement Studio folder. And next you need to go to Properties and make sure you update the license file according to this public key token. Then you are ready to start creating your code. In my example I've just created this simple form with a text box like this, and a button and a label. So when I click this button, the data from the OPC server should appear in the text box. So let's see how the code looks like. So I can just right click here, view code. So here I have included the namespaces. Here we create a new data socket object. Here we specify the URL to the tag. And then here we connect to the server, in this case just read access. And then here is the event handler for the button. So when we click the button, this code should be executed. So in this case we use the update in order to get the latest value from the OPC server, and then I just use the toString in order to get the value from the OPC server into the text box like this. So let's start running the code. Click the start button, and then we are good to go. So let's open our OPC Explorer, and here I have the Bucket Brigade Reel 4 tag. So I can just right click, write a value 15 and click OK, and then go back to our Visual Studio program and then click read OPC, and you see the latest value from the OPC server appears in the text box like this. So let's change it to 20, click OK, open our Visual Studio Code, click read OPC, and you see the value gets updated like this. Next we create a simple OPC write example where we are going to write values from Visual Studio to our OPC server. So here you see the example. Here is our application in Visual Studio. We just have a text box, a label, and a button. So when we enter a value in the text box and click write OPC, the value in the OPC server should be updated. Here you see a part of the code. So it's almost identical to the read code. So you need the same namespaces and assemblies, and we need to specify the OPC tag like this, and then we connect to the OPC server, but in this case we use the access mode write. And then next we take the value from the text box and put it into a variable, and then we update the OPC data socket value with the specific value, and then we run the update method in order to write the value to the OPC server. So let's try this example inside Visual Studio. So now I have opened my project in Visual Studio. It's almost identical as the read project. In this case I'll just call it OPC write, and then we have the same thing here. Under references we need to add those assemblies, so just right click, add the reference, and then select browse and find your assemblies on your hard drive. It should be typically in the program files, National Instruments, and the Measurement Studio folder. And next you need to update the license file with the latest public key token like this. In this case I created a form like this. So in this example we are going to enter a value in the text box and then click the button in order to update the value to the OPC server. So let's see the code for this. Click view code. We use the same namespaces. We create a data socket object. We specify the OPC URL, in this case Bucket Brigade Reel 4, and then we connect to the OPC server using, in this case, access mode write. And then in the event handler for the button we just create a variable and then read the value from the text box into that variable, and then we use the data socket data value property to set the value, and then we use the update method in order to update the value and write it to the OPC server. So let's run this example. We click on the start, and then in this case you can click a value here, let's say 22, and click write OPC, and then you can open the Matricon OPC server and you see the value has been updated. So let's do it one more. Click 45, write to OPC, and the value is updating like this. In this example we are going to both write and read in the same example. So our application should look something like this. We have a text box for writing to the OPC server, and then we have a text box that shows the value from the OPC server when we click the OPC read button here. And then if we have the Matricon OPC Explorer open, we should see the value change according to that. So here you see the entire code for this example. In this case we create two data socket objects, one for read and one for write. We specify the URL, and then we connect using the read mode, and then we connect using the write mode. So we have two connections open at the same time. And then we have a write event, so when you click the write OPC button this code should run. So we just update and the OPC server like this. Here is the write. So the value from the text box should be converted to a double and put into a variable, and then we update the server with the value. In the other case, in the read, so when you click the read button, this piece of code should be executed. So we just get the latest value from the server, and then we put the value from the server into the text box like this. So let's run this example also inside Visual Studio. So this example uses the same references, so we need to add those manually, and then we have the also we need the license file, and here is our application. So we have two text boxes and two buttons. So let's run this example, and then I can type a value here, 22, write to OPC, and then let's open the Matricon OPC server, and you see it gets the value from our application. And then we can read the value here, so just click the read button, and then you see the value from the OPC server is put into this text box. Type 25, write and read. So let's take a look at the code for this example. Click View Code. So here is we create the data socket objects, the URL, connection to the server, and then here we have our event handler for the two buttons. In this case, the read button. So we just get the latest the latest value from the server, and then we put the value into the text box. Here in the right, we do the opposite. So we get the value from the text box into a variable, and then we use the update in order to put that specific value to the OPC server. In this example, we will show a little bit more realistic examples. And so in this example, we are going to use a timer, because normally you need to read or write the values from the OPC server at specific intervals. So you typically don't push a button in order to write or read from or to the server. So then the timer is good to use. So it's kind of a loop. Then next, typically we want to plot the values in a plot or a chart inside Visual Studio, and then we can use the waveform graph that is included in the Measurement Studio. And of course, the last part, you should use some object-oriented programming, meaning you should create your own classes and use those inside your code. Let's take a look at this example. Here, let's start with the timer. So the timer, you can just drag it from your toolbox into your user interface. And then first we need to specify that in the initial part you should just start the timer, and then you should have a separate event for the timer, and that event should occur according to the interval you set in the property. So inside that event you can read values or write values from the OPC server. In this example we are going to read from the OPC server, we are going to do some scaling, and then we are plot the values inside the plot like this. Here we see how we can trend data using the Measurement Studio and using the waveform graph control. It's quite easy to use it. You just need one single piece of code like this. So this is the waveform graph object, and this is the method you can use, the plot y append, and then the input to this method is just the value you got from the OPC server in this case. In this example I also used these objects to show the value, the last value from the OPC server, and then I've used some scaling to also show the value in Fahrenheit. And here you see the plot in order to see the historical data from the OPC server. So let's run this example inside Visual Studio. So here I have opened my example inside Visual Studio, and we need to do the same here. We need to add the references and the assemblies we need. Just right click on the references, and then we need to update the license file, and then we can start creating our code. So here I have created a form. In this case I've used the graph object and those controls in order to see the last value and also the scaling to Fahrenheit. And also here I have dragged in the timer from the toolbox. So let's see the code for this application. View code. So here is the included the namespaces. Here we create the data socket object. Here we specify the URL and connect to the server. In this case we just read the value. Then here in the timer tick event, we have put all our code. So here we just get the latest value from the OPC server, and then here we have used some scaling to convert it to Fahrenheit. In this case, I have created a class. We find the class in the folder classes which I have made, and just open that class, scaling, and then I have created two methods in this case, one that convert from Celsius to Fahrenheit, and then another method that convert from Fahrenheit to Celsius, like this. And that method, I use it here, and then I update the GUI with this information, and here I plot the value inside the waveform graph, like this. So here I start the timer in the form, and also in the properties, when I click on the timer, here I can specify the interval. So it updates every 1000 milliseconds, like this. So let's run our program. Click the start. You see, so now I can go to my Matricon OPC server and the Matricon OPC Explorer. So just right click on our tag, write value, write 26, like this, and you see I got 26 from the OPC server, and also convert the value to Fahrenheit and also plot the value. So let's change the value once more in our OPC Explorer, change it to 27, like this. Go back to our application, and you see the value is updating automatically using this timer, and also it plots the historical values like this. That's all for today. Thank you.